Hey fellow coders, welcome back. Today we'll discuss a very important graph question called is graph bipartite? So this video is divided into three parts. First we'll discuss what a bipartite graph is with a real life example. Second we'll discuss its properties that will help us to solve this problem, and at last we'll code this out. So without wasting any time, let's get started. First, let's understand what bipartite graph is. I'll be using a real life example to explain this, but before that, let's first see the book definition of it. So, a bipartite graph is a graph that can be divided into two sets of vertices. So, like if there are five vertices there, it can be divided into two sets of vertices. Let's say first set having three vertices, another set having two vertices, such that no two vertices is in the same set are connected by any edge. So if let's say vertices 2 and 3 are in set 1, so there should be no connection between 2 and 3. Similarly, there should be no connection between any other nodes in set 2. So hope you are clear. Now let's see a example of what bipartite graph is and how it is used in real world. Uh, so let's say there are we'll understand the relationship between a student and subject. Let's say there are two type of student. One is a freshman and another is a senior. And freshman can study three subjects, that is math, science, and English. And senior can study two subjects, that is calculus and physics. Now there is a relationship between student and subject. So let's say we have this thing here, and we have three students, three senior student S1, S2, and S3, and we have three freshman student F1, F2, and F3. Similarly, I have written down the subjects where each letter represent the subjects here. So let's try to like make a relationship here. So if you see, let's say this is a student senior 1, and let's say he is taking calculus class. This student is taking calculus class. Let's say there is another student senior 2. This guy is taking two classes, calculus and physics, and this guy is a senior, and let's say it is just taking one class, that is physics. Okay, so we have established this relation. Now let's try to establish relationship between freshmen and their subjects. So freshman 1, let's say it's taking science and English. Freshman 2 is a topper and he's taking all three subjects. And let's say freshman 3 is only taking one subject, that is English. So if you see this graph, we can actually we can actually divide this graph into two sets. That is, first set is this one and another set, that is this one, and we can actually see that there is no connection between there is no relationship between any other students, and there is no relationship between any subjects here. So hence we can say this graph is bipartite. That is, we can divide this graph into two sets such that there is no connection or there is no edge in a same set. So bipartite graph has a very interesting property, and this is actually the property we will be using to solve this question. So let's see what that property is. So the property says that we can color the whole graph using only two colors such that no adjacent nodes have same color. So let's say if we try to color this with green, so what we can do is we can color its neighbor with yellow. Okay, so now if we have colored this with yellow, we can use a different color to color its neighbor, that is adjacent nodes. So we can use green here and we could use green here. So if you see, if this graph is bipartite, if you see, yes, this graph is bipartite because we can actually divide this graph into two nodes such that the first set has nodes as 1, 3, and 4, and another set have node 2, and there if you see, there is no connection between these two things. So 1 is actually connected to 2, and 2 is connected with 4, and 3 is connected with 2. If you see, there is no connection between the nodes here. Hence this graph is bipartite, and it also follows this property. Actually all bipartite graph follows this property. Let's see the other graph. So let's try to color it using two colors. So if we color this with Green, what is its neighbor? Its neighbor definitely has to be a different color. So if we use yellow here, now we are stuck, because here if you see, we can't use green because green, its neighbor is green, and we can't use yellow also because its neighbor is yellow. So we can't color it with these two colors, and we have to use another color. So hence this graph is not bipartite because it does not follow this property. Now let's try to see how we can code this out. Let's say this is the graph given. So what we will do, we will maintain a color array. Okay, we'll maintain a color array, and that is will have all the nodes, and one represent green color and two will represent the orange color in this color array. So now let's see what we can do is we can do a simple DFS, that is depth first search. For that, let's say we will start from node 0, and let's say we'll assign the in first node as color green, that is 1. So for 0 we can assign it to 1. Then what we can do is for all its neighbor we can assign just the opposite color what we assigned. So if we have assigned 1 here, for 2 we could assign orange, for 3 again it's an opposite color, we can assign orange, and for 4 it's an opposite color, we could have assigned orange. Okay, so 4 also we have assigned orange. Now we have visited and there is no neighbor to it, so we could go back. There is no neighbor to it, we could go back. There is for 4 there is one neighbor, so the opposite color is 1. So for 5, so there will be actually one more value here, that is 5, and we could have assigned 1 here. Now let's say 5 has another neighbor as 1. So what we could do, we can assign an opposite color as 2 here, and we could assign 2 here. So if you see, we have completed this color array, and at for each component of the graph, we can see that if any given point of time, if my adjacent nodes have same color, then we could have written false. So let's say if there was a connection between these two, so what would have happened, if you, it means that this is one is also assigned here and one is also assigned here. So for 5 I will check all its neighbor, that is 2 and 4, are they having same color? If there was a connection, then these two are having same color, we could have written false. Since there is no connection, so for 5 it will check all its neighbor, that is 4 and 1, and there is no connection between like if there are connections and they are of different colors, hence we can say that it's a bipartite graph, that is all nodes are, we can assign two different colors such that no two nodes have same color. Hope you have understood this part. Now let's try to write the same thing in code. Now let's try to code this out. I'll be using Java. You can use any language of your choice, but the logic will remain same. So now first let's try to write the DFS function. But yeah, before starting that, let me give what is the input is. So the input will be the agency matrix where let's say this is at 0th index, that is 0 is connected to 1, 2 and 3. This is at 1 index, that is 1 is connected to 0 and 2, that is, and similarly 3 is connected to these three and 4 is connected to these two nodes. Now let's try to write the DFS first. So we'll writing a normal DFS with one caveat, that is we'll also maintaining a color array. Do note that I won't be writing using a visited array, and we can actually use the color array to see the visited. So let's say what I'll do is I'll mark something called as source here. DFS will pass source, will pass this adjacency matrix, that is graph that is already given, and will maintain a color array. Okay, so here what we will do is before that, what we can do is we can try to visit all the neighbor of its source. So we can simply write this for each loop, that is visit all its neighbor. So this will visit neighbor one by one. So now let's say if a neighbor color is not assigned, that is a neighbor color is 0. So I'll be using two things here, that is I'll be using two color 1 and 2, and 0 means that no color is assigned. So if my neighbor color is 0, that is no color is assigned, and this also means that it is not visited. Then you go ahead and assign a color. So how we will assign a color? If my source, that is parent color, was let's say 1, then assign the opposite color to its neighbor, that is now my neighbor color will now be 2. Else my parent color is 2, so what will be my neighbor's color? My neighbor's color will be 1. Hope you are clear on this part why I'm writing this. So we are using two colors, 1 and 2, two numbers to represent two colors. Okay. So once I am done with this, I'll call DFS recursively again. But this time, if my let's say DFS returns me false, so I'll also return false here. So I'll call it for my neighbor, pass all those things what we have defined earlier, and if this returns, I'll return false here. If this is not true, then I'll return false. Okay, so now we'll actually writing the function that will check that my parent and its neighbor don't have same color. Once all color is assigned for that particular vertices, I can simply check all my neighbors for that source. So I'll write a for loop, each loop here. If any point of time, if my color of source and is equal to color of neighbors, that is source and neighbor, that is two adjacent nodes have same color. What does that means? It means that my graph is not bipartite, so return false. If after everything it still have not written false, then return true. That means my graph is bipartite. So we have written the important part here. Now we'll just write some boilerplates here. So what we can do is we can define, let's say, let me define an n that will be graph dot length. We can define a color array which will be nothing but n, that is number of nodes. And then we have to go to all its component. So we'll traverse from I equal to 0, I less than n, I plus plus. And what we can do is, if my color is still not defined for that component, if my color of I is equal to 0, that is, it is not visited and my color is not defined, so assign a color to it. So you can use either of them. I'll assign 1 here, so my first color is 1. Now call DFS for it. I graph, we'll pass all those things what we have defined, and color. If for this component returns me uh, false, that it means that graph is not bipartite. You also return false. Don't check for other components, else we can return true. Yeah, that's it. Let me try to run it. Okay, what I am doing here in, okay, there is no semi. Okay, I'm written double equal to here. Let me remove it. These are some silly mistakes. Let me try to run it again. Okay. So yeah, that's it. Hope you have enjoyed the video. If you have enjoyed the video, don't forget to leave a like. See you on the next one. Bye.